Hello there, trig students. Dr. Shragi here. We're on our next day of working on line in trigonometry. This is section 6.2 in your book. Now, we just did section 6.1, which was the law of sines, and you could smell that coming a mile away that there was going to be a law of cosines if there was a law of sines. The good news is the situations for applying the law of cosine will be somewhat simpler than the ones with the law of sines. I think that with the law of sines, it was pretty straightforward until you got to those SSA problems. Then you had to do those tests. There were 6 different possible outcomes. Nothing like that's going to happen with law of cosines. The bad news is the actual equations of the law of cosines themselves are a little bit messier. Now, of course, you don't have to memorize the law of cosines because the book will, we will have open book tests, and they are the 6 different forms of the law of cosine are all given in a blue box with yellow highlighting at the top of page 413. And so I think we're going to be able to kind of keep this under control for you here. Once again, this is the amazing thing about these laws of sines and laws of cosines is they are for oblique triangles. A different kind of trig class might even try to prove that for you and prove how these work. Effectively, you have to break the oblique triangle up into 2 or 3 right triangles, and it can be done. We're not going to do that, but it could be set up that we could do it. But we don't need to actually do that in order to enjoy the fact that there are these laws of sines and laws of cosines. Now, law of sines, I'm not going to say it was fun, but the pattern was easy to see. Sine A over little a, sine B equals sine B over little b, equals sine C over little c. It's pretty straightforward. Don't you dare try to memorize these guys. There are 6 forms of the law of cosines, and they're all just rearranging. You might notice that all of them have a different variable on the left-hand side. The 3 in the first column all have little a, little b, and little c as what you're solving for on the left-hand side. Whereas on the right ones, the left-hand side of those equations are all about angles, angle big A, angle big B, and angle big C. So it's not so hard to know about there's 6 different forms of it. You just use the form for what you're trying to solve for right now. The law of cosines is specifically for 2 types of problems. Don't get me wrong, it would work for any of them, but it is specifically helpful for the problems that are side, 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 or SAS, side, angle, side problems. Boy, that terminology back in geometry about side, angle, side, and side, side, angle, and all that kind of stuff turns out to be pretty useful actually in these later classes. Now, your book doesn't actually come right out and say it, but you should in general want to think about those ones on the right column as being the ones you're going to use if it is a side, side, side problem. In other words, if you're given all 3 of the sides of the triangle, well, you actually then have everything on the right-hand side of those equations. I mean, you have little a, you have little b, and you have little c. So if you're looking for b, big B, the angle big B, use the middle one of those. Or if you're looking for the angle big C, use the bottom one of those. Now, notice it doesn't give you big C, it gives you cosine of big C, but we know how to handle that kind of problem. We'll just then take the inverse cosine of both sides. So we'll do an example of that in just a few minutes. On the other hand, that other column on the left-hand side, those are for ones where you know 2 sides and the angle between the 2 sides. So it's a side angle side problem. That's how that terminology works, right? SAS, because 2 sides and an included angle. Then you can find the third side using whichever of those formulas has the right letter. So like if you are looking for side A and you already have side B and side C, then use that top equation. If you are looking for side B, excuse me, the hiccups, use the middle equation. So, I mean, the equations themselves are messier than the law of sines, but the actual math of doing them is just tedious and careful. You have to be precise, but they are pretty straightforward problems here. So let me just do an example here. Now, I hope this showed up well on the screen for you there. I've got a triangle there. This is actually example 1 in the book. So if you, that triangle turned out way lighter than it looked on the screen originally. Anyway, there's a triangle there, ABC triangle there. And in this particular case, I gave you all 3 sides of the triangle, but none of the angles. That Makes it a side, side, side problem, SSS, which means if I bring up that list of forms of the law of cosines, we can see that we're going to want one of the ones on the right-hand side. Those are the ones where everything to the right of the equal signs is just a bunch of sides. It's all the little letters. Okay. Okay. Now, in practice, any of those would work. You could use cosine A, cosine B, or cosine C and find one of the angles, or all of them. Now, your book makes a suggestion that I've never been entirely sure where they're going with, but maybe I'm missing something here. The book suggests always starting with the angle that is opposite the longest side. So, like if you go back and look at our triangle there, the longest side is, excuse me, is little b. It's 19 units long. So we should be working with the angle big B, the one that's opposite that side, little b. Honestly, I'm not entirely sure. I think that makes a huge difference. I see in a few, maybe it's a 1% better thing. Okay, but I'll show you that in just a little bit here. All right, so we're going to do like the book does, though, and say, let's start with the cosine. Let's look for big B. Let's use that form of the equation. Will that have everything we need? Yeah, if you look at the right side of that highlighted equation there, we have little a, we have little c, we have little b, and we have two a and c. Sounds good. Hey, boy, watch those pluses and minuses in there. What a mess. Yeah, don't try to memorize these equations. They're just where sadness comes from, okay? So, all right, if the cosine of b equals, and then we just sort of plug all those numbers in. As long as you're careful there, you'll get that the cosine of b equals, in this case, negative 0.45, whatever. Then we can get big B by just taking the inverse cosine of both sides of the equation. On the left-hand side of the equation, inverse cosine and cosine cancel out. We've only done that trick like 100 times this semester already. And on the left-hand side of the equation, it's inverse cosine of that weird number, negative 0.45089. And you run that through a calculator or whatever, you get 116.8 degrees. Okay, great. Not such a big deal. And we could certainly keep doing this. Notice I've changed it up here on this triangle here. I guess you can't see. I've now marked that up there. Now, honestly, we could keep using the law of cosines. We could keep doing that and now do angle C. I'm sorry that I'm so yawny today now. First I had hiccups, now I've got the yawns. Or we could do angle A. But to be honest, it's not really the best strategy. It's look at those equations. They're just full of places to make mistakes. Oops, I forgot the minus sign. Oops, I forgot the divided by 2 part. It's just where sadness could happen. Once you get one of the sides, one of the 3 angles, actually from there on out, you could always solve the problem with law of sines. So if you need all 3 angles, just finish it out. Excuse me, I'm so yawny. And then finish it out with the law of sines. And I'm not going to go do that all carefully because I don't want these videos to get so long and tedious. So just go look at page 413 to see how they finished up this problem doing law of sines. But by this point, you've done so many law of sines problems. My guess is you could do this one no problem. Now, why does the book recommend finding that angle opposite the longest side first? Let me give you their terminology. What they say is that this tells you whether or not the angle that's opposite the longest side is going to be obtuse. Well, that's true. Okay, first off, let's be clear about this. Only one angle on a triangle can be obtuse, right? If you had more than one angle that's obtuse, it does not make a triangle, right? So at most one angle is obtuse, maybe none. And I guess it will be the angle that is opposite the longest side. So I guess you would know whether that angle's obtuse. And it is true that on law of sines, some of the tests, well, I mean, I guess you always wanted to know, first of all, whether the angle was obtuse or not. So, okay, I mean, I guess this maybe saves you a little bit of time. Seems like it'd be just as good to go the other way. I mean, if I picked one of the sides angles opposite the shortest side, I would know that's an acute angle, and then I wouldn't have to do that step at all for the law of sines. I just don't know that I think that they thought this through that well. I'm not sure. Whatever, it's not critical one way or the other. You'll get the right answer no matter which way you do it. So these side problems, these ones where we just have given all 3 sides of the triangle, They're always straightforward. They're messy, but there's no nonsense like there was for those SSA problems where they had all those conditions and we had to test H. We had to know whether the angles were acute or not. Like 6 different possibilities. None of that's going to happen with SSA. Okay, great. What about the others one? We said that another thing we could do with law of cosines were the side angle side problems. Okay, that's where you're given two sides of the triangle, you know their length, and you know the size of the angle in between them, that included angle. All right. Well, I told you at the beginning of this lecture, that's what the ones on the left side of that left column on the law of cosines are for. You just choose which of those three forms of the law of cosine is the one that tells you the side you don't yet know. All right, so like in this problem here, if I look at my triangle, I should use the arrow here, the arrow, the mouse. I know side B, I know side C, I know the angle in between, so it's a side angle side problem. And the only side I don't know, excuse me, this is what that break is doing. This time of being stuck at the house is doing for me. I don't get enough sleep. Anyway, is side A. So we're going to want to work with that first form there, where what we're solving for on the left is, and then everything, if you look at that right side, that's all what we have. B's and C's and big A's. Oh, we're in good shape then here. We're just going to work with the side what we don't know, with the side we know. Everything on the right-hand side we've got, and we just solve for the A. In this case, A is equal to this strange number 5.4072, something like that. And keep a bunch of digits around so that you're precise. You can always round later. All right. Well, now, I mean, could we keep using the law of cosines? Absolutely. Nothing is stopping us. But it's certainly more error prone. I mean, there's pluses, there's minuses, there's twos, there's so many places you could make a mistake. So on the other hand, we now know sine of big A and we know A. So I guess we now can just go ahead and compute this using the law of sines. And again, that's a lot less likely to produce errors than this is. I mean, wouldn't that be, no, I don't mean that the method isn't going to produce the errors. The problem is you might make a mistake. So actually, I think we have this under control. And in fact, I don't think we need to finish this problem out. I'm going to point you to page 414 where this problem came from. And you can see for yourself how they finished it out if you're still not so clear on the law of sines. But of course, if you're not clear on the law on sines, talk to me. I want to make sure that you stay on track on this stuff. These I wrote wrong. There's a mistake on that slide. I said SSA problems, but that's the ones that are tricky. SSA were the ones that had the 6 possibilities. This is I'm sorry, this is SAS. The S the SAS problems like this are always straightforward. They're not like those messy SSA problems that had all the conditions and possibilities. Here's how you remember which ones are the trouble. Okay, you didn't hear it from me, but don't call them SSA problems. Call them ASS problems. Does that help you remember? Think it through. Maybe find some way to remember that they might be a pain in the SSA. Whatever works for you. But that's how I remember it. Those are the ones that are always causing trouble. They're the ones that they really should be called ASS problems. Okay, angle side side says side side angle, and then you'll remember those are the ones that always have all those weird conditions and are hard to solve. When people talk to me about the law of sines problems on Ivy Learn, what they most of the time what was going wrong is they just weren't being very precise. They weren't keeping the angles to a few decimal places, or they weren't keeping the sides to a few decimal places. And then when it came time at the end, then they ended up being slightly off just because they had rounded too early or whatever. In general, keep a couple extra digits, maybe out to 4 digits or something like that when you're working with these problems. And then if the problem in the end tells you round to 2 decimal places or something, then do the rounding. Okay. There is a way to do it where if you have been working with the right number of digits all along, but that's a fussy thing you learn in like a chemistry class or a biology class. Let's not get bogged down in that. We're all working with calculators here. We can just keep a couple extra digits. It's no big deal. I do want to point out to you though something interesting that comes from the law of sines. Again, maybe if we weren't having all the strangeness in the world right now, we would be actually deriving it, but we're not going to do that. Oh, just a second here. I am sorry that my phone is ringing. I'm going to go and just mute that for a second there. And I am going to tell you about Heron's formula. It is an interesting formula that comes from the law of cosines. You can do some rearranging and so on and show that this has to be true. Heron was an ancient Greek mathematician. He lived about 100 years before the birth of Christ. And his real name was actually Hero. Then the adjective form of his name is Herons. Hero of Alexandria was his name, which is awesome. And he proved that there's a nifty way to use the law of cosines in order. Again, keep in mind, we're talking like more than 2,000 years ago. He found that there was an easy way to find the area of a triangle if you just know the sides. So, like, here's this formula there. Let's say we got some triangle, and you know this side, and this side. How do you know the area in the triangle? I mean, in grade school, you would have to figure out the height of the triangle or whatever, and all that good stuff. You had to have the given. Now, no, actually, all along, you could have been using Heron's formula, where you know all three sides, A, B, and C. Along the way, though, you have to also compute this term S. S really looks like the average of sides A, B, and C. But if it was the average of sides A, B, and C, it would be A plus B plus C divided by 3. And that is a mistake students make all around the world at this point in the assignments. It's A plus B plus C over 2 to be S. But when you have that S, then the area of a triangle is just the square root of S times S minus A times S minus B times S minus C. Um, Is that easy? Kind of. Yeah, I mean, don't get me wrong. That's a lot of arithmetic in there, and you have to be very careful when you're putting it all in your calculator and stuff like that. But actually, this is pretty straightforward. I mean, if I am doing land surveying and I want to know what the size of this triangular field is, I'm not sure if fields are often triangular, but whatever. If I just measure the three sides of it, Heron's formula right away gives me the area of it. I just have to compute that S and then use that formula there. It's actually pretty easy. You just have to be careful. All right. That is kind of the theme, though, in trig, isn't it? You just have to take your time and be careful with all of these things. So let's talk about the assignment associated with this letter, like this lecture here. Once again, the main part of the assignment is on Ivy Learn. There is no assignment on paper this time. There aren't as many questions as they were for the law of sines thing. Just so we're clear about it here, there is also a Google Classroom exit ticket for you for this time. But let's actually take a minute here and go look at what's on Ivy Learn. Over here to Ivy Learn. And I am currently in the teacher mode. Let me switch it over to student view. All right, now we're looking at it the way students would see it. And you can see that those are those activities for law of sines that you did the last time. And here are two activities about law of cosines. And I even have them grouped out. There's the SSS problems, and then there's the SAS problems. And last time, while there was 5 of each of the questions, this time there are 3. So there's only 3 law of cosines problems with SSS, and then 3 law of cosines problems with, sorry, kids are coming in from backyard playing. And there are 3 problems from SAS. And then there are 2, I think, only problems that use Heron's formula. All right. So it's smaller groups of problems. Hopefully you'll have less frustrations with all of this and so on. Again, just be really precise. Keep all your digits, keep a bunch of extra digits until the end and then round it to whatever the problem needs. All right. Well, things are getting crazy as my kids are coming in the house, and I think that's a good place to cut off the lecture. Please let me know which questions you have. According to the documentation from EBSC, at the present time, this assignment is in theory due at the end of the day on Wednesday, April 8th. Seems like a long ways away. I would get going on this earlier rather than later. All right, please let me know if you have any questions, and please take care of yourselves.